Hello, hi, and welcome to what will actually be two videos, one on series and one on parallel circuits. The reason being, talking for about 15 minutes on the two types of circuits, I'm always more likely to make a mistake and say something stupid, so I've split this one up into two different videos to make things a little easier for me. First thing that I'm going to do is just bring up a summary of the two types of circuits there. That is everything you need to know. I'm not going to talk through them in any more detail looking at that, but what I will show you is the simulation on the computer, and hopefully that will show you everything you need to know. So this is a series circuit. It's a series circuit because there is only one loop, there's no junctions, there's only one path that the electrons can flow through. So in the same way that a TV series is a series of programs that you have to watch in order, the same thing is the case here. So the electrons come out of the battery, they move through the leads, through one component, through the second component and back. There's only one path that they can go. They have to go through things in a series. Now we'll start off just looking at current. So the first idea, remember, is that current is the speed that those electrons are flowing at. So hopefully you can see just by looking at these ones, these are my little electrons, they're flowing around, and hopefully you should be able to see that the speed of those electrons is always the same. It's the same here as it is here as it is here. So if we start sticking an ammeter in, and remember an ammeter has to be placed in series, so we place one ammeter here, we can see that the current here is 0.45 amps. Now if that's the speed that the electrons are going at there, hopefully we'll be able to predict what the current will be here. If I stick another ammeter between my two lamps, 0.45 amps, hopefully you can see that the speed is the same. And if I stick another ammeter in here, we should be able to see that once again the current is 0.45 amps. So in a series circuit, the current is always the same at every different point. Why? Well, you can see if that electron's moving, it will push that electron. That electron will then push that electron, and so on around the circuit. So if this electron speeds up, that electron will speed up, that electron will speed up, and so on all the way around. Reminder that when we're measuring the current, we put the ammeters in series in our circuit, and that's just because the current is always the same all the way around the circuit. So if I want to measure the current in that circuit, it has to be in the actual circuit itself. So that's the current, but what about potential difference? The potential difference then, remember the potential difference is the energy transferred by the electrons. So I measure potential difference in parallel to the circuit. Sorry about that. We measure the potential difference in parallel to a component. So here it's got a reading, the battery's got a reading of 9 volts. What that means in very, very simple terms is that these electrons, I always like to think that each electron is leaving that battery with 9 volts of energy. Now, everything in science is fair. These two lamps are identical. So if each electron travelling through the lamps has 9 volts of energy to give, you should find that it will give that energy equally between the two lamps. So my first lamp has 4.5 volts supplied to it. My second lamp should also have 4.5 volts. Now that's the summary, or the summary for voltage in a series circuit is this. The voltage supplied by the battery is the same, or is shared, between the components in the circuit. So if my battery is supplying 9 volts and I've got two lamps, 9 volts will be shared between the two lamps. So you've got 4.5 volts there, 4.5 volts there. I'm not going to show you this one, but you could pretty much predict if I get rid of one of those lamps so that I've only got one lamp in the circuit, what would the voltage be for that lamp? Well, you can work it out. The voltage supplied by the battery is the shared between the lamps. If there's only one lamp, that lamp will get all 9 volts. If I add another lamp to the mix, again, hopefully you'll be able to predict this. 9 volts once again supplied by my battery. How many volts will each lamp get? Well, if they're identical, they should each get 3 volts. So 3 volts there, 3 volts there, 3 volts there. So once again, the voltage supplied by the battery is shared between the components. It does not have to be equal. For example, I could alter this lamp and increase its resistance so that now this lamp gets 4.5 volts. Still 9 volts supplied by the battery. That means the remaining voltage has to be supplied or shared, between these two lamps. So if it's 4.5 there, 4.5 for both of those means how much for an individual lamp? 2.25. 2.25 for that one, 2.25 for that one, 4.5 for that one. So if you get a calculator out and you add 2.25 to 2.25 to 4.5, it will come out as being 9. So one last summary there. In a series circuit, the current is always the same. The voltage supplied by the battery is shared between the components in the circuit.